Like Peter said, my name is Matt Keeler. I'm a software engineer on the Consul team here at HashiCorp. And today I want to talk with you a little bit about how to manage ACL permissions in Consul. This is going to be focused a lot on OSS and just general usage, but then the second part of this is going to be focused on using ACLs with namespaces and delegation, things like that. All right, so before we can get into the bulk of this, there are prerequisites that we should put out there as things that you must do before you can actually have a secure system and start using tokens. So the first one of these is you need to have enabled surf encryption or gossip encryption so that other unauthorized agents cannot just join your cluster out of the blue. Second thing that you need to do is enable TLS encryption. This is includes both RPCs, communications between Consul clients and Consul servers, as well as TLS for the HTTPS server. Both of these are necessary so that when you are using your tokens and things to access the API, that they won't be transmitted plain text over your network and potentially sniffed and stolen. So, and the last prerequisite we have here is that besides just enabling ACLs, you should always be in a default deny mode. You should not use default allow. Also for the purposes of the demos, you will need to have bootstrapped your master token, whether it's via the CLI, API, or in one of the configuration files. And so also for setting up all of this, I'll have links more towards the end, but all of our Learn resources, there's a guide for each one of these. All right, so Consul has many Apple resources. There are 4 that we're going to talk about and focus on in this demo. There's 2 others related to auth methods and binding rules, which are essentially how to take an external identity and get these resources attached to it. I'm not going to focus on those. So starting here, the first resource that we're going to deal with is the token itself. And this is really just a set of API keys that is associated with one or more policies, roles, and service identities. It has a secret portion of it, has an accessor ID. And whenever you make a request to Consul's APIs, you have to specify that secret ID as a bearer token to authorize your request. Next, we have the policy, which is a rule set. So all the permissions when you grant or deny access would be in a policy. Potentially you're granting permissions on Consul's KV store or in service discovery permissions, things of that nature. Ideally, these rules should be all related within a singular policy and scoped to, I think, one logical operation. And so a good example of that logical operation could be if you're using Consul's distributed locking functionality, then you would need permissions in both the KV and session. But they're kind of, in order to use that functionality, it's like that one operation you're doing. So you group those into a singular policy. Next, we have the role, which is just a grouping roll-up of a bunch of policies and service identities. And I like to think of these as aligned more with a user or a service, some sort of entity that needs to perform multiple types of operations. So you would want to have a role for it and then assign multiple policies, one for each one of those operations to the role. And lastly, and we're not going to cover it too much in the demos, but there's a service identity, which is just a synthetic policy that grants some predefined permissions, which is the ability to register and manage the service that's defined by the name of that service identity, a sidecar proxy for it, for your service mesh, and it also grants general service discovery permissions. All right, so with that, we're going to go direct into a demo. So in this demo, we're going to start out pretty small. We're going to start, and I'll show you over here. We're going to deploy a web service, and this is, for the time being, could be something like a static website, but we want to be able to register this service. And so it needs its own tokens, and we're going to set that up. And eventually, over the course of this demo, we're going to evolve this into multiple services that are going to need to communicate with each other, perform service discovery, things of that nature. But we're going to start small and work our way there. So over here in the terminal, I have deployed 3 instances of the same service, and they're all currently getting permission denied when attempting to register themselves. So the first thing we need to do is go and create some policies that allow us to have access. So go in here, we'll call this manage web, because I want to be able to manage this web service. I need to grant write access on that service name. And even though I mentioned that a role is a great way to roll up permissions for a service, I'm going to pretend for the time being that I don't know about roles. And I'm just going to create tokens linked directly to these policies. And over the course of the demo, we'll show you why that was not a great choice. And also, I have 3 service instances. So I'm going to duplicate this token a few times because I don't want to share my tokens. Back over here in the terminal, I have some scripting around to import these tokens into my shell so that when I redeploy, the tokens I just created and the policies that are associated with are now granting me the permissions necessary to do what I wanted to do. And we can also verify that they were registered over in the console UI. All right, so that's great. If we have our static website, whatever it is, and we can now register the service and things will be able to find it. But we want to do more than that, right? So now I'm going to be deploying a little bit more complex configuration where now instead of having one service, we have a web service, an API service, and a database service. And in this scenario, our web service is going to want to use both the API and database services, and our the API service itself will also want to use the database service. For the time being, they're still getting permission denied errors because we haven't granted them any permissions or any tokens. And I could do that same thing through the UI again, but instead I have scripted this using our CLI and have got it all set up so that they will, I did the exact same thing. So the script there that I just ran created another policy for managing the API, one for managing the database. And finally, it created a whole bunch of tokens. And so now all the service registrations are happy, but that doesn't really help us because they can't do anything with each other. So I'm gonna enable them to start discovering each other so that they can figure out how to route to another, right? They need to find each other's IPs. And when I redeploy this, take a second, there we go. Can see here that all the service registrations are successful. There's no permissions denied errors. We have the API service, which is attempting to do service discovery on the database service, like we mentioned it would. It's not finding any. It has a count of 0, even though there's 3 database service instances available. Our web service, similarly, is also looking for both the API and DB service and again, coming up with nothing. And the reason why is because it doesn't have permissions to it. Instead of permissions denied errors, many of the console APIs that list things, such as service instances, will filter the result set. So you will end up seeing nothing, even though the reason why is it's you don't have permissions to see it. So let's go ahead and fix that. And again, I mentioned that you should try and scope your policies to sort of logical operations, but we'll pretend that I don't know about that for just a moment. And I'm going to assign all these permissions that our web service needs right in the one policy that it's already using. So I'm granting it read permissions on that database service so that it can discover that, read permissions on the API service. And then there's also this node rule, which is necessary so that the services, when it finds them, it can read its node information as well. And I will go ahead and save that. And pretty soon, yep, there it is. Our web service now is discovering the API service and database service as we wanted. So that's great, but now we need to do the same thing for the API service. And we could go in here and just copy paste some rules, the same ones we used before, maybe get rid of the one that has it read itself. But we don't want to do that because we're starting to get a lot of duplication here. And if it's just a couple policies that you have duplication in, maybe it's not that big of a management burden for you. But if you have 100 services that all need to access your database service and find it, then managing that over time would become pretty difficult. So I'm going to back out this from this policy, and we're going to do it the right way now. So I'm going to create a few different policies, and it's going to create the first one here, which is allows the node permissions. Second one to be able to discover the API service. And then finally, the third one is to be able to discover the database service. Here we go. So at this point, everything that didn't actually affect anything. All we did was create some policies. So we also, before, we didn't bother creating a role. And this is why that's problematic. We can go in here and I can attach a bunch more policies, all those policies necessary to one of these web service tokens. And it will work. As you can see over here, it already changed. Now it's able to discover those instances that it wanted. But that didn't affect these other two web tokens. If I had 10 or 20 of these, you don't want to go and have to edit 20 tokens just to do that. And this is where a role would have been the proper way to do this. And so we'll fix this up. So I'll create a role. We'll call it service web because this is the role for what it means to be a web service. We're going to grant it all those policies that we just created, including the one that allows it to manage its own service registration. And unfortunately, because we didn't do that role before, we have to go in and assign it to all these tokens after the fact. I would say in general, if you find yourself duplicating or cloning tokens or just creating identical ones, not using the cloning functionality, you probably want to ensure that you're using a role. That way, when you add policies or your permissions evolve over time, it's a lot easier to just have it apply to all of your tokens. And so, okay, we'll fix up these other two. And I'm also not removing the duplicate policy just because it saved me a couple clicks right now. Internally, when Consul resolves these tokens, it will dedupe all the policies, so you don't have to worry about that. All right, so all my web services are now fine. They're discovering everything as desired, and we want to do the same thing for both the API and DB services. Again, I have a little automation set up. It's using our Consul CLI to do the exact same thing. If I refresh over here, you can see that our API tokens and our DB tokens were all converted over to using roles. And now everything's happy. Everything that wants to discover everyone else, that's all good. But now we're going to go even further. So now, in this scenario, we want a little extra coordination between the things that use our DB service and the DB service itself. So maybe in this case, the database service needs to advertise in the Consul KV store like a particular protocol that it wants to be communicated with. And then the other services, the API and web service, need to look at that KV entry, figure out what protocol, and it's part of their discovery of that service. So at this point, we have our permission denied errors back. So the API and web services are failing to read the KV data at this DB protocol KV path. And here's one. The DB service is failing to write it. So because we have these finer grained policies, we can go back and fix this up real quick. And the first thing we need to do is grant our database service the permission to write that KV path so that it can advertise what protocol it wants to be communicated with over. And pretty immediately, that should, yep, there it is. Here it is. The database services are now writing it. They're not getting permission denied. We didn't have to modify their role. We didn't have to modify their token. And the reason why it was a good spot to put that is because conceptually, being able to manage that database service, part of that is involving setting up this advertisement. So conceptually, it makes good sense to put it with that. Similarly, all of the other services, our API and web, it's part of discovery to be able to figure out what protocol this should be using. So a good place to stick that is in our Discover DB policy. And when we'll go ahead and save it, and everything should, yep, everything's good now. So we can see that we're reading the value out and everything is happening perfectly. And so hopefully what I've been able to show here with this little demo is the value of roles and finer grained policies and how manage them in this way. And this was on a very small scale, but at a much larger scale, when you have more service instances and when you have many more types of services and that use common functionality, being able to make fewer edits to propagate all the permissions that you need to where they are needed. If you do it in this manner, it can save you a lot of editing of many things. And so go back over to some slides. So next, we want to talk about namespaces and ACLs and how they interact with each other. So there's two big features that I like when they're combined. And the first is with delegation of ACL management. So if you are using Consul Enterprise and you now have the ability to create another token and give it out to another user, or maybe you have automation to do this, so maybe it's another service, and grant them the ability to create policies, roles, and tokens within their own namespace. And restrictions are in place to keep them from targeting other namespaces, so they can have their own little view of the world and manage ACLs themselves. So if you're in a large organization and you don't want to have your one security team manage ACLs for every one of your application teams, this would be a great feature for you. The second cool feature is the ability to infer a namespace for a request from that Apple token being used. And so what normally happens is when you make a request in a console cluster when ACLs are not enabled, it will just default to the default namespace. But when you have ACLs enabled, it will default the namespace to the token's namespace. And to show you some of these features, we're going to go to another demo. Same cluster here, but I have reset my demo environment. We're going to do this. And for this demo, it's going to be mostly similar to the previous one, except all these services are going to be namespaced. The web service is going to go into NS1, the DB service, or the API service in NS2, and then the DB service in NS3. All right. So I deployed the web service again. You can see it's getting permission denied in NS1 this time. And the first thing we need to do is actually create a namespace. It's pretty simple. You can do it through the UI, you can do it through the CLI or API. One thing to note here is that each namespace can have some default roles and policies associated with it. And when you set these up, every token in that namespace will automatically get these permissions. So if you wanted to grant service discovery to everyone, you could do it here. But for the time being, we're going to leave these blank and come back to that in a moment. All right. So now that we have our NS1 namespace, we don't want to have to manage that namespace. We want someone else to do it. And I'm currently using the master token. I have permissions in multiple namespaces because of being that master admin, if you will. But I want someone else to handle this. So if we go over to the ACL specific to this namespace, you see there's no tokens, there's no roles there. But when we created it, it injected this namespace management policy for us, which grants us pretty much every permission that is available in that namespace. Similar to the global management policy that you'd find in the default namespace, except it's slightly more limited because some permissions cannot be granted within a namespace, such as operator permissions or node write. So we're going to delegate our Apple management for this namespace to someone else. And it's pretty simple. You just create a token with that namespace management policy. And so I want to be that person, so I'm going to use this token. And you'll see it'll change my UI a bit. I no longer have permissions on any other namespace, so there's no drop down. I can't see the default namespace, and I won't be able to see the other namespaces as we create them. And so now we'll do sort of the same thing we did before, except within a namespace. Create this manage web policy and save it. So one other thing to note here is that this policy is basically this policy. I'm going to get the indentation right. And so you don't have to put this in there because the policy exists within the namespace. Consul can infer this extra namespace block for you and will just act like you wrapped it in there, but it's fine if you put it in there or not. All right, so now that we have that, let's create our role because we learned from last time that would be a good thing to do. And for now, we're just adding the service discovery permissions. Oh, not the service registration permissions. And we need to create a few tokens. And again, I'm using this delegated management token so I don't have to, so my super admin, if you will, doesn't need to interact with this. I can do it self-serve. I'll duplicate it a few times. And things are good. Except now I'm trying to do service discovery and can't for the same reasons as we had before, except it'll be a slightly different solution. This little script I have, it went ahead and created the other namespaces and other tokens just like I did right now, including with the roles involved. And I'm going to deploy all of those. And so now cross-namespace permissions in Consul are the purview of the super administrator who has a token in the default namespace. And just to show you that, me still being this delegated admin, I'm going to try and create a policy where I would target API service in namespace 2. And it's going to tell me that it can't do it. And that's because we're restricting it. You cannot target any namespace outside of your namespace. So I'm in NS1, I cannot target NS2. And that way we're preventing leaking of permissions. So then how do we actually do this is the question. Let me stop using this token and go back to my master token. As you can see, I have my permissions back. We created both NS1, NS2, and NS3 namespaces. All right, so like I mentioned, we have to do this, we have to grant those same permissions somehow. And the solution is those default policies and roles that you can attach to an individual namespace. So I'm going to create the few policies similar to what we created before, except these have to target a specific namespace. Otherwise, they would be implicitly scoped to being in the default namespace. So I created one to discover the API in namespace 2. We're going to create a similar one to discover nodes. But this one, I'm just going to grant it blanket permissions across all namespaces. And then finally, we need the same permissions in, well, similar permissions on the DB service in namespace 3. All right. So at this point, we still don't have the permissions. They're still not working. And we need to go back over to manage our namespace and grant these permissions as defaults. So namespace 1 is where we have our web service, so it needs permissions on both. Namespace 2 just needs the ability to discover nodes and the database service. And as soon as we apply these, all those service discovery counts go back up. And everything's good. So the few things tried to show here are how to set up cross namespace permissions, and that was with the default roles and policies that are attached to the namespace configuration itself. How to delegate ACL administration, which is to just give a token ACL write permissions in a particular namespace. So the last little bit to show is an example of that namespace inference based off tokens. So going over here, I'm going to pick one of those web tokens from the NS1 namespace. If I was to run console catalog services with that token, it's going to show me just the web service. And that's I haven't specified a namespace in any form, whether it be an environment variable, which isn't set, or in the command line, but it's defaulting that to NS1 for me. It's not the default namespace because its ACLs are enabled. I can still, because I have permissions, target a different namespace, but that's specifically if I want to care about other namespaces. So in this manner, like whether you're using the API or the CLI, we can do that defaulting for you. So some app developers, maybe they don't need cross namespace access or permission, so they don't have to necessarily care that they're in a namespace all the time, and they don't have to add that to their requests. All right, let's see. So this was the same QR code that Cody put up just a few minutes ago. It will link out to a bunch of different resources on the Learn websites. So, and just a couple conclusions to wrap up. I've automated a lot of those demos, and as your infrastructure scales and as your ACL needs scale up, you will probably want to do the same. We have our CLI to help you out if you like scripting things. Our HTTP API, everything that we've done can be done through that API as well. There's other things such as secret engines for Vault and other integrations as well. And so finally, there's a few, and these are all linked in that previous QR code, but there are guides specific to setting up all of these things on the Learn platform as well. And that's it for me. Thanks a lot, and back over to Peter.